Hello children, welcome to Physics with Sanoop, Healing Medical Aspirations. See, this is neat previous year questions. So let's go to first question. A vehicle travels half the distance with a speed v and remaining half distance with a speed 2v, then its average speed. In average speeds, there are two different cases. See, in one case, total time of traveling will be divided. If total time of traveling is divided into equal intervals, then the average speed will be the arithmetic mean. See, instead of dividing time, suppose the total distance is divided into equal parts, then the average speed will be the harmonic mean. Here the distance is divided. So, distance is divided into two equal parts. So, the average speed will be, this is the most convenient form, or it is the most beautiful form. 2 by V average equal to 1 by V1 plus 1 by V2. If the distance is divided into three equal parts, it will be 3 by average equal to 1 by V1 plus 1 by V2 plus 1 by V3, like that. Okay. Now then V average equal to 2 V1 V2 divided by V1 plus V2, and here first half of the distance is covered with a speed V and the rest is covered with a speed 2V. So if we put values V and 2V, we will get 4V by 3. So 4V by 3. Okay. Now children, we have another typical example. The displacement time graph of two moving particles make 30 and 45 degree with the x-axis as shown, the ratio of their respective velocity. We have displacement time graph, and slope of the displacement time graph means displacement, change in y divided by change in x. So change in displacement by change in time, or it is velocity. So slope represents velocity. Here we have got two straight line graphs. So the slope of the first graph and also the second graph are constants. Slope constants means they are moving with the equal, they are moving with the constant velocities. Okay, and that velocity is tan theta. So we have tan 30 divided by tan 45. Tan 45 is 1. So the ratio will be tan 30, or it is equal to 1 over root 3. Okay. Now next question, if a car at rest accelerates uniformly to a speed of 144 km per hour in 20 seconds, it covers a distance of. Here the acceleration is assumed to be uniform. Body starts from rest and final velocity is 144 km per hour. How do we convert this 144 to meter per second? This is 144 into 5 by 18. Okay, that much meter per second. So it is 40 meter per second. Whenever the actually displacement is always average velocity into time. That is unconditional. But average velocity is equal to the arithmetic mean of initial and final. Means average velocity equal to this one, u plus v by 2, is true only when the acceleration is constant. Okay, here we have constant acceleration. So we can use u plus v by 2 for the average velocity. Initial velocity is 0 and final velocity is 40. So 0 plus 40 by 2. Okay, that is equal to 20. Then 20 into the time is 20 seconds. So 20 into 20 will be 400. Okay, so this is the displacement. And now we have a wonderful previous year question, and here there is a fixed wooden block. A bullet is fired into the wooden block. As it penetrates 24 centimeter, its velocity falls to 1/3 of its initial velocity u, and it further penetrates, comes to rest at the other end of the block. Okay, then what is the thickness of the block? When a body starts from rest and moves with a constant acceleration, acceleration constant means velocity changes equally in equal intervals of time. Then ratio of displacements in successive equal intervals of time means first t seconds, next t seconds, next t seconds, like that. Ratio of displacements will be 1:3:5:7. Okay, whatever be the duration of this interval. Now same thing can be applied in the reverse order also. Means when a body comes to rest with uniform deceleration, ratio of displacements in successive equal intervals of time will be 5:3:1. When accelerates, 1:3:5. When comes to rest with the uniform retardation, 5:3:1 if there are 3 intervals. If there are only 2 intervals, it will be 3:1. If there are 4 intervals, it will be 7:5:3:1, like that. Okay. Here, see, after penetrating 24 centimeter, its velocity falls to u by 3. Okay. Then only 1/3 of its initial velocity remains. Okay. And it comes to rest at the other end of the block. Suppose the time required to reduce its velocity from u by 3 to 0, see, let it be t. Okay. The retardation is assumed to be uniform. See, it loses 1/3 of its initial velocity in time t. Then it must have elapsed 2 such intervals. Means in first interval t, it loses 1/3 of its initial velocity, and in next t, it loses the second 1/3, and last t, it loses the final 1/3. So there are 3 intervals, and the ratio of displacements as it comes to rest will be 5:3:1. If it is not so comfortable for you, you can always start from the 0 velocity ends. Then 1:3:5. Okay. If you are not sure of see this ratio in the reverse order, then always you start from the 0 velocity end with the 1:3:5, like that. Here we have 3 intervals, 1:3:5. Okay, now see, 5 plus 3, 8 parts are equivalent to 24. 8 parts of distance are equivalent to 24. So that each part will be 24 by 8, means 3. See, here we have only one part, means it is 3. So the total thickness of the block will be 24 plus 3, that is equal to 27. Okay, this one. The motion of a particle along a straight line is described by this one. Okay, where x is in meter and t in seconds. The retardation of the particle when its velocity becomes 0. Okay, so the position is given as x equal to 8 plus 12t minus t cube. If we differentiate it once with respect to time, we will get velocity. Okay, see, 8 being a constant, its differential is 0, and 12 we can take outside. The differential of t is 1, so 12 into 1 will be 12 only, minus differential of t cube will be 3t square, minus 3t square. Okay, see, if we differentiate once more, we will get the expression for acceleration. So acceleration a equal to dv by dt, and this is see, differential of 12 being a constant, it is 0, and minus 3 is constant, and the differential of t square will be 2t. So minus 3 into 2t will be minus 60. So acceleration equal to minus 60. Whenever you want to find the acceleration, you have to put that time in this expression. Okay, that's all. Here we have to get the acceleration when velocity is 0. If you know the time, we can simply put the value of that time in this equation. See, a equal to minus 60, we will get the acceleration. But the time is when the velocity becomes 0. So first we have to find when the velocity becomes 0. We have the expression for velocity here, 12 minus 3t square. Okay, when this 12 minus 3t square equal to 0, then t will be equal to 2 seconds. So we have to find the acceleration when time equal to 2 seconds. See, acceleration is minus 60. Okay, so when t equal to 2, acceleration will be minus 6 into 2 minus 12. That is acceleration. See, we have to find see, the retardation, means negative of acceleration. Acceleration is minus 12. So negative of acceleration will be plus 12 meter second raised to minus 2. Okay, now let's go to the next question. A particle starts its motion from rest under the action of a constant force. Distance covered in first 10 seconds is s1, and the distance covered in first 20 seconds. It's not a next 20 seconds, it is first 20 seconds. See, when a body starts from rest, s equal to half at square. Okay, so first s1 is distance covered in first 10 seconds, and s2 is distance covered in first 20 seconds. So s2 by s1 will be t2 by t1 whole square, as s is proportional to t square. So 20 by 10 whole square means it is 4. Okay, or let us say s2 equals 4s1. Okay, so s2 equal to 4s1. Now see, next question. The position is given in terms of the time. Okay, and what will be the position of this particle when it achieves maximum speeds? Okay, see, if you differentiate this position once, you will get the expression for velocity. Okay, position is 9t square minus t cube, and its first derivative, that is velocity, will be 18t minus 3t square. See, when velocity is maximum, its first derivative will be 0. Okay, let's again differentiate velocity. Okay, means the first derivative of velocity, or it will be the acceleration, that is 18 minus 60. When v is maximum, dv by dt equal to 0, that is a equal to 0. Okay, so t will be equal to 3 seconds, or velocity is maximum when time equal to 3 seconds. We have to find the position when time equal to 3 seconds. See, at any time, if you want to find the position, you have to replace t with that time. Okay, this is the expression for the position. We have to find the position when velocity is maximum, and velocity is maximum when t equal to 3 seconds. So we have to find the position when t equal to 3 seconds. So in the expression for position, you have to simply put t equal to 3. Okay, so we will get 9 into 3 square minus 3 cube, and that is equal to 54 meter. Okay, so the first option itself is the correct answer. Now let's go to the next question. A particle moves along a straight line OX at time t. The distance position is given as x equal to 40 plus 12t minus t cube. How long would the particle travel before coming to rest? Means the displacement of the particle, see, when it comes to rest, that we have to find out. See, position is given. If we differentiate it once with respect to time, you will get the expression for instantaneous velocity. So 40 being a constant, its differential is 0, and differential of 12t is 12, and differential of minus t cube will be minus 3t square. Okay, see, when velocity equal to 0, put 12 minus 3t square equal to 0, and you will get t equal to 2 seconds. So when time equal to 0, initially the position is 40 meter. And when time equal to 0, means when the velocity becomes 0, our body will come to rest at x equal to, say, 40 plus 16, 56 meters. Okay, body starts from x equal to 40 and body comes to rest at x equal to 56. So the displacement travel will be 16 meter. Okay, so this is 16 meter. Now the next question, this is an important question, a typical question that you should know. Okay, you should understand. And see, a car accelerates from rest at a constant rate alpha for some time, means it reaches its maximum velocity. After that, it experiences deceleration at a constant rate beta to come to rest. Okay, if the total time elapsed is t, the maximum velocity acquired by the car is, fine. Okay, suppose the maximum velocity acquired by the car is v. So during the accelerated motion, its velocity changes from 0 to v in time t1, where t1 is the time for accelerated motion. So see, acceleration is change in velocity by time. So time will be change in velocity by acceleration. Okay, so t1, time for accelerated motion, will be change in velocity by acceleration. See, in physics, change means always final minus initial. Here the body starts from rest and moves to a velocity v, acquires a velocity v. Okay, so final v, initial 0. Okay, final minus initial divided by acceleration alpha. During the decelerated motion, initial velocity is v and final velocity is 0. So the change will be 0 minus v. Deceleration is beta, so acceleration will be minus beta. Okay, time is change in velocity by acceleration. Okay, t1 is the time for accelerated motion and t2 is the time for decelerated motion. So t1 plus t2 will give you the total time elapsed. So t equal to t1 plus t2. Okay, t1 we have v by alpha, t2 we have v by beta. V is common to both, so v can be taken out, and inside the bracket there will be 1 by alpha plus 1 by beta. That is equal to total time elapsed. Okay, now see, keeping this v here, take this, hold this 1 by alpha plus 1 by beta like this and bring to left side, then it will come in the denominator, means t by 1 by alpha plus 1 by beta v. Okay, when this is simplified, this alpha beta t divided by alpha plus beta will be the maximum velocity. Okay, so alpha beta t divided by alpha plus beta. Okay, Now a bus is moving with a speed of 10 meter per second on a straight road. A scooterist wishes to overtake the bus in 100 seconds. Okay. If the bus is at a distance of 1 kilometer from the scooterist, with what speed should the scooterist chase the bus? Initially, suppose the bus is the reference, then scooter is 1 kilometer behind the bus. Okay, finally when the scooter overtakes the bus, it will be near the bus. So from 1 kilometer behind the bus to near the bus. Okay, so displacement of the scooterist when the bus is taken as the reference. Okay, from bus is taken as the reference. Initially 1 kilometer behind. Now near the bus. Okay, so the displacement will be 1 kilometer. Relative displacement of the scooterist with respect to bus. Okay, and the relative velocity, suppose it is v relative. So relative displacement by relative velocity, that will be equal to time. Okay, so relative velocity will be relative displacement divided by time, and that is equal to 10 meter per second. Relative velocity of scooterist with respect to bus. Okay, see, velocity of scooterist minus velocity of bus, that is equal to relative velocity. So velocity of scooter equal to relative velocity plus velocity of bus, that is equal to 20 meter second raised to minus 1, because the speed of bus is given as 10 meter per second. Okay, so this will be the correct choice. Now let's see the next question. A train of 150 meter long is going towards north direction at a speed of 10 meter per second. A parrot flies at the speed of 5 meter per second to the south. So the train and the parrot are moving in opposite directions. So the relative velocity of the parrot with respect to train will be that is 5 minus 10, it will be 15 meter per second. Okay, and see, displacement of the parrot with respect to the train will be equal to the length of the train. Okay, and it is 150. So the time taken by the parrot to cross the train or to move across the train, it will be, see, a displacement of parrot with respect to train divided by velocity of parrot with respect to train. Okay, that is equal to 150 divided by 15. So it is 10 seconds. Okay, 10 seconds. See, I have explained earlier that when two bodies are moving at the same time, you need not apply equations for two bodies separately. For the two bodies together, you can apply single equation. Only thing is that all absolute quantities are to be replaced by relative quantities. Okay. And here we have another wonderful previous year question, that is, a horizontal bridge is there, a body is thrown from the bridge with an initial velocity 4 meter per second vertically up, and it strikes water after 4 seconds. Then what is the height of the bridge? Displacement is irrespective of the path followed, it is always from the initial to the final position. See, the body started from the bridge and ultimately it strikes water. So the displacement is from the initial to the final, means this is initial and this is final. So displacement is downwards. And that is equal to height of the bridge that I have written here, S equal to H, directed downward. Initial velocity is directed upwards. Now see, acceleration due to gravity means the attraction of the earth. Irrespective of the direction of motion, acceleration due to gravity is directed downwards throughout the motion. When body moves up, g is downwards. When body goes down, g is downwards. Okay, so acceleration due to gravity is downwards throughout. So we have initial velocity upward, acceleration downwards, and displacement also downwards. We have to find the displacement or the height of the bridge. So we have to apply the equation S equal to ut plus half at square. There are quantities directed upwards and also quantities directed downwards. Out of these one direction, any direction, you can choose as positive. Only thing is that opposite should be negative. Okay, so see here, displacement I have taken positive because I have written only h, not minus h. So downward displacement I have taken positive. So all the quantities directed up should be taken as negative. in this particular case, because I have already chosen downward direction positive. Okay, so upward velocity that I have taken negative, acceleration due to gravity downwards, so it should be positive. Okay, so here minus 4 into 4, that is minus 16, and 4 square is 4 square is 16, divided by 2 is 8, into 10 will be 80. Okay, so minus 16 plus 80, that will be 64 meter. Okay, so we will get the beautiful answer 64 meter. Okay. Okay, next question, see the ratio of the distances travelled by a freely falling body in the first, second, third and fourth seconds are in the ratio 1:3:5:7. It's called Galileo's law of odd numbers. Okay, so anyway this will be the correct answer. Next, a ball is thrown vertically down with a velocity 20 meters per second from the top of a tower. So initial velocity is downwards, final velocity also downwards, acceleration due to gravity also downwards. Okay, so all the quantities are directed down. It strikes the ground after some time with velocity 80 meters per second, then the height of the tower is. Okay, G is given as 10. See, V square equal to U square plus 2AS. See, all the quantities are directed down. So S is equal to V square minus U square divided by 2A. And this is 80 square minus 20 square divided by 2 into acceleration due to gravity, that is 10. Okay. Now see here 80 square and 20 square. 20 square is common, that we can take out. See what will remain here? 4. Okay, so 20 square common factor that I have taken outside, then 4 square minus 1. So 400, that is 20 square, and 16 minus 1, that is 15. Okay, divided by 2 into 10. Okay, so that will be this 2 into 10, that is 20, and 400 we can cancel. So in the numerator there will be 20 into 15, that is equal to 300 meter. Okay, so 300 meter, this is the correct answer. Okay. Next, a ball is dropped from a high-rise platform at t equal to 0 starting from rest. After 6 seconds, another ball is thrown down from the same platform with speed v. The two balls meet at t equal to 18 seconds. What is the value of t? Okay, so first ball is released. Okay, and after 6 seconds, second ball is thrown. Okay, when t equal to 18 seconds, they meet, means their displacement will be the same. So the first ball must have travelled for 18 seconds, while the second ball has travelled only for 12 seconds. Okay, first ball for 18 seconds and second ball for 12 seconds. So the displacement of the first ball after 18 seconds and displacement of the second ball after 12 seconds will be the same. Okay, that displacement we have to equate. As the first ball starts from rest, it's uv0, ut0. Then what remains? Half a t square. Means g by 2 time is 18. Okay, g by 2 t square. So this is the displacement of the first ball. Now the second ball must have travelled only for 12 seconds, starting with a velocity v. So its displacement is ut, means v into 12 plus g by 2 12 square. Okay, that v we have to find out. So here we have 12v. When that g by 2 12 square is taken to the left, it will be g by 2 into 18 square minus 12 square, and this is of the form a square minus b square, and it can be converted as a plus b into a minus b. So g by 2, a plus b means 18 plus 12, that is 30, a minus b means 18 minus 12, that is 6, and here we have 12v. Okay, now this this v will be this 12 and 6 we can cancel, 2 remains here, and 2 30, that is 15, 150 divided by 2, that is equal to 75 meter per second. Okay, that is the correct answer, right? Yeah, a ball is thrown vertically up. It has a speed of 10 meter per second. When it has reached 1/2 of its maximum height, okay, how high does the ball rise? See, when it reaches 1/2 of the maximum height, its speed is 10. Okay, see, at half the maximum height, means further it will have to go half of the total heights. See, here the velocity is 10. At the highest point, velocity will be 0. Okay, and it moves with a constant acceleration. So average velocity is simply the arithmetic mean. Okay, during upward motion, if the acceleration due to gravity is negative, see, and g is 10 meter per second square, what does it mean? During upward motion in each and every second, its velocity will decrease by 10. And downward motion in every second, its velocity will be increased by 10. Okay, now here the velocity is 10. As it goes up, its velocity will decrease by 10 meter per second in every second. So in the first second, its velocity will decrease by 10. It has only 10 meter per second velocity. So after 1 second, its velocity will be 0. What does it mean? It takes only 1 more second to reach the highest points. Okay, average velocity is 10 plus 0 by 2 and the time taken is 1. So the displacement will be 5. Okay, 5. That is half of the height. H by 2 equal to 5. So the height will be h and it is equal to 10 meter. Beautiful. Okay, right, 10 meter. Now a ball is thrown vertically up with a speed u. The distance covered during the last t seconds of its ascent. Okay, see, from here to here, see, this is the last t seconds of its ascent. See, if the time taken to go like this is t, then when it comes down in the next t, it will reach here. Okay, now the question is, what is this much height? See, what is this much height? The same thing can be considered as the distance downward also. If it takes t seconds to move upward, the same t seconds will be taken to come down also. Okay, so when you consider this downward motion from here to here, the time required is again t. Initial velocity is 0. Okay, so u0, ut0 and this displacement will be g by 2t square. Okay, in t seconds when it comes down. So when it goes up also, displacement will be g by 2t square. Okay, so g by 2t square. When air resistance is neglected, when a body is moving under the effect of gravity alone, the time for upward motion will be equal to the time for downward motion. Okay, that is the idea behind this, right?